In this video, we'll be looking at section 1.6, which covers inverse functions. If f of a equals b, then a function g of x is an inverse of f if and only if g of b equals a. The inverse of f of x is typically notated, as f superscript -1 of x, which we read as f inverse of x. So equivalently, if f of a equals b, then we can say f inverse of b equals a. So inverses are this idea of undoing each other. Please be careful. This raised -1 is just a notation for inverse functions. It does not mean we are using an exponent or a power of -1. It just means the inverse. Well, if we're going to take the inverse of a function and only get one value out, we're going to have a one-to-one function. If you think back to when we were talking about one-to-one functions, those are the ones where each input has exactly one output and each output has exactly one input. We were actually doing these inverse situations before. We're just looking at them more generally now. So if f of 3 equals 5, we want to find f inverse of 5. Well, they're saying if we take the inverse, this output is now our input, so we just have to switch. The output of the inverse is the input of the function. If f inverse of -1 equals 4, we want to find f of 4. Well, in our mind, x is always our input. But if we're dealing with an inverse, then things are switched backwards. It's giving us f inverse of the output equals the input. So they're saying if f inverse of our y value equals our x value, find f of the x value. Well, that's just going to be the y value, which we are told is -1. Next up, we're going to find inverse functions. So the way we typically do this is we are going to replace function notation. So if you see f of x, then you're going to replace it with y. Then you can solve for x. From there, you can replace x with an inverse function notation, replace it with f inverse of x, and replace y with x. This I always found slightly confusing, but it's the way your book goes about it. The way I was taught in school, and a lot of my students say they remember this bottom way. They replace the function notation, f of x, with y. So that's the same no matter what. From there, switch the x and y. It feels weird, but it'll be okay. Where you see an x, it's now a y. Where you see a y, it's now an x. Then we're going to solve for y. We're going to get the y by itself. Once that happens, we can replace y with the inverse function notation, f inverse of x. As a cool note, if you want to make sure you found the correct inverse, you can use composite functions, f of f inverse of x and f inverse of f of x. Since inverse functions essentially undo each other, you should get x in both cases. And you get to practice composite functions, and who doesn't want to do that? So we want to find the inverse functions of the following. First up, we have f of x equals 2x plus 3. I'm going to go about this the alternate way just because in my experience more people have done this with the switch x and y way. So first up, we change our function notation to a y. So our f of x is now a y. Then we switch the x and y. So my y becomes an x. My x becomes a y. I now need to solve for y, get the y alone. So I can subtract 3 from both sides, and I get x minus 3 equals 2y. If I divide both sides by 2, I get x minus 3 divided by 2 equals y. Our final step is to return to function notation, but because we switched the x and y, we need to make sure we're using inverse notation. So f inverse of x is going to replace my y, and that gives me x minus 3 over 2. We can check our answer by using composite functions, so I'm going to try that. If I find f inverse of x, that's going to be 2 times my inverse function, x minus 3 over 2, plus 3. The 2's divide out, leaving me with x minus 3 plus 3, which is x. So that one checks out. If I check my f inverse of f of x, that's going to be x gets replaced with 2x plus 3. Then I still have a minus 3 in my numerator over 2. That's 2x over 2, which is x. Since I got x in both cases, I know I got the right answer. Let's try the second one, g of x equals 1 over x. I'm going to replace the function notation with y. Y equals 1 over x. Switch the x and y. X equals 1 over y. Solve for y. I'm going to cross multiply in this case. I'm going to think of my x as x over 1. So I get x times y equals 1 times 1, which is 1. To get the y by itself, I divide both sides by x, and I get y equals 1 over x. Since I switched my x and y, I will use inverse notation. F inverse of x equals 1 over x. That is my inverse function. You will notice this is the same thing as the function I started with. That's weird. Let's check our work by using composite functions. F inverse of x is equal to, I'm going to plug in 1 over x where I see an x. So 1 over x. If I keep, change, flip, that gets me x. If I do f inverse of f of x, then I'll get the exact same thing because they're the exact same function. So in that case, the function g of x is its own inverse, and that should be a g inverse. My mistake. Stay consistent with your lettering. One thing I do want to note that's not written in these slides anywhere is that functions and their inverses are symmetric over the line y equals x. So you know how we switch the x and the y? That gives us this. If you don't believe me, feel free to graph 2x plus 3 and x minus 3 over 2. You'll notice that they're symmetric over the line y equals x. And then this 1 over x is one of our toolkit functions. It's the one that looks like that. If you put the line y equals x in there, it's symmetric over it. Pretty cool. Feel free to check that out a little bit more and get some more practice.